Hello everyone, sorry about the length of this video. I apologize, there's lots to go over here. So, domain, it's still the X's that get used. Range, it's still the Y's that get used. This is still the numbers you're allowed to input. These are still the numbers that you're allowed to get as outputs. Okay? What's different about these is that they continue forever. The first one that we did, it ended. It ended here. It ended here. And these other ones, they didn't go on forever. They started and ended. So what's different with these is that they go on forever. So let's look at the red one first. If this continues forever to the left, and we're looking at input, and that's not very straight at all, I'm sorry, and this continues this way, what X's get used? Isn't it all of them? All X's, it goes on forever to the left, so all the X's to the left get used. It goes on all the way to the right. All the X's get used to the right. So every number works. So in that example, the domain is all real numbers. And I'll show you how to write that. Okay? I'll abbreviate that in a minute. The range. If this graph goes forever to the right, doesn't it go as high as it wants? If it goes forever to the left, doesn't it go as low as it wants? We're looking at the y values. It's your, whoops, how far does the graph go up and down? X's were how far does the graph go left to right. It goes as high as it wants. It goes as low as it wants. So all real numbers work. Whoops. All real numbers. Okay, there's a way to abbreviate that. And it's this funny uppercase R with two vertical parts that you draw off the leftmost R, the leftmost vertical piece. That's all real numbers. That's what that symbol means. And when we look back at the delta math, there's a choice, all real numbers. And you'd hit that. Okay? The blue one. The blue one's a little bit different. It starts here and goes all the way down. So if I'm looking at domain, it starts at 3 and goes as far right as I want. Domain is left to right. So it's starting at 3 and goes all the way to the right. So that means x is greater than or equal to 3. I'm assuming it's closed, so it has equal sign. Range, it's your up to down motion. It starts, so that coordinate is 3, 0. It starts at 0 and goes as far down as it wants. So that means your y values are less than or equal to 0, because it's starting at 0 and goes as far down as I want. So it's everything less than or equal to 0. Again, I'm assuming that endpoint is closed. Okay? So this is looking at ones that go on forever, that they are not segments that are stuck between 2 points. Okay? So let's go on to the next one. Okay, so several things need to happen here. I need to show you guys how to put these in your graphing calculators and graph them. Okay? And if you don't have them, I'll show you how to use delta math to do it. So what you would do to graph the first one is you would hit y equals. So let's quit that. Let's just go back to the main screen. So second quit. Come on, there we go. That's the main screen. If you hit y equals in the upper left corner, it has room for you to type an equation. I just need x squared. So you go x squared, and then on the far right, you hit graph. There it is. Okay? If you're doing it in delta math, you go up here, you click on that, you choose graphing calculator, and you would type x on the keyboard. And let's see, you're going to have to use the caret symbol, caret, which is that upside down V, 2, plot. There it is. Okay? So whichever one you're using, either the Delta Math or your TI-84. And if you have a Chromebook, TI-84, this should already be on the Chromebook. It should already be there. Okay, so coming back to here. Domain, it's your left to right motion. you are assuming these go on forever. When you look at these go on forever. All these, they go on for, there's arrows on them. They go on forever, okay? Domain is left to right. How far left does the graph go? Well, it goes on forever. It keeps getting wider. How far right does it go? It goes on forever. So your domain is all real numbers. Range. Range is your up to down motion. It goes as high as it wants, but it's starting at 0 and goes as high as it wants. So range is y is greater than or equal to 0. Okay? If you type this one in, you would just go to your graphing calculator, y equals, you would type x squared plus 2. Oops, I need to get rid of that thing. Arrow over. I'm going to delete it. Come on, delete. Delete. There we go. And now graph. Whoop, there it is. Okay, so there it is. Domain is left to right. How far left does it go? Well, it goes as far left as it wants. How far right does it go? As far right as it wants. So it's all real numbers. Range. It can go as high as it wants, but it's starting at 2. So y is greater than or equal to 2. Notice when it's all reals, I don't need to put the x with it. Okay? When it's not all reals, then I need to put the x with it. And that's why I'm putting the y with the range, because the range deals with the y's. X cubed, okay, on your graphing calculator, y equals, I'm going to clear all that out, x, this symbol is called a caret, like the carrot you eat. Hit that and type 3. There's x cubed. Bloop, there it is. Okay, there it is. Domain. How far left can you go? Well, I can go as far left as I want. So it continues down further and further and further. How far right can you go? I can go as far right as I want. The graph continues to get wider and wider and wider. So it's all reals. Oop. Range. Can it go as high as it wants? Yes. Can it go as low as it wants? Yes. So the range is also all reals. Okay? You would do the same thing on your graphing calculator to get 13 that I just did. You type it in, this is what you see. Notice it will still go as far left and as far right as you want. I know it looks like it's going vertical, but it really is widening and really is continuing to go as wide as it wants. Heck of an R, there we go. That's better. Can it go as high as it wants? Yes. As low as you want? Yes. So that's also all reals for the y's. So the questions I'm asking you guys, domain, can it go as far left as it wants? Can it go as far right as it wants? These are questions that I'm asking. Range, can it go as high as it wants? Can it go as low as it wants? Those are the questions I'm asking. Okay, because this deals with the y's, this deals with the x's. Okay, to type this in. Oops, it's the wrong one. Bloop. Let me call that back down. That's the one I wanted. Y equals. If I clear that out, I would just type, no, there's a difference between the subtraction and a negative. That's a negative symbol. Don't hit subtract there. It'll say error. It's the negative, which is down here. Parenthesis, x plus 3, close the parenthesis, to the 5th power, caret 5, graph. And there it is. Okay, that's what I've got over here. There's arrows. It will continue to go as far left as it wants and as far right as it wants. So all real numbers. It will go as high as it wants and it will go as low as it wants. So all real numbers. Okay? To show you how to get an absolute value on your graph. Okay, so y equals, I'm going to clear this out. Again, it's the negative. So I need to hit the negative button. Now I need to get this absolute value on there. The fastest way to find it is that in this catalog down here, it has a list of all the functions possible. If you notice it's in blue, if I hit second, the blue key, catalog, it's the very first one. Just hit enter. There it is. X plus 3, Now I need to come out of those absolute value bars and type -4. Now that's subtraction, not the negative. That's subtracting 4. Okay, it's not the negative symbol. Okay, it's the subtraction one. Graph, and there's the graph. Will this go as far left as we want? Yes. Will it go as far right as we want? Yes. So the domain is all reals. Range, will it go as high as we want? No. It will only go as high as, that little itty bitty graph, it looks like -4 is as high as it will go. But it will go as far down as you want. So the y's are less than or equal to -4. Okay? Square root graph. Lots of them to show you guys. Y equals, clear it out. There's the square root. Okay? So I will go second square root. Was it x plus 3? Come out of the square root, -5. Not -5, but -5. Graph. There it is. So it's starting here and running to the right. And it will continue to go higher and higher and higher. I know it doesn't look like it is, but it does, okay? It will continue to go higher, and it does continue all the way to the right. So the domain, it's starting at -3, and that looks like -5. Starting -3, -5. Okay, so the domain, x has to be greater than or equal to -3. Range is from this point up. I know it doesn't look like it's getting higher, but it really does. Okay? Y is greater than or equal to -5. Okay? This one, if you typed it in, it begins at -4. So I'm trying to speed this video along. I won't type that one in. It's already here. 5, -4, 5. Notice those numbers are here, but how I'm reading them, yeah, I won't explain that now because we're just focusing on domain and range. But I can get it off the graph, -4, 5. Okay? The x's start at -4 and go to the right. So the x's are greater than or equal to -4. Y's are from the value of 5 down. So y is less than or equal to 5. Okay, lots of information there. I'm sorry there's more that's coming. Okay, to type this in, you go to your graphing calculator, y equals, clear that out. It's just 1 over, well, how do you do the over? Divide x. Okay, that's one way you can get there. Another way, not to confuse you, if you go alpha y equals, and just choose number 1, just enter, it gives you the fraction. Now, how do I do that again? Alpha y equals, number 1, enter. 1 is on the top, I can arrow down, x is on the bottom. There you go, graph. Okay, so a couple things that are happening here. This continues to go as high as it wants, as far right as it wants, as far down as it wants, as far left as it wants. But it's not touching the y-axis. There's a name for this sucker that runs through here. It's not touching the x-axis. Both of these things, it's a name, and I'm sorry we got to go there. ASYMPTOTE. It's a line that the graph doesn't touch or cross. It's called an asymptote. There's a horizontal and vertical asymptote here. Okay? So, domain. Can the graph go as far left as it wants? Yes. Can it go as far right as it wants? Yes. It continues off this way. But there's a gap in the middle, and the gap is occurring at 0. So the x's can be any number it wants, but not 0. So it's easy to describe what it can't be. X can't be 0. Range. It can go as high as it wants. It can go as low as it wants. But it can't be this horizontal asymptote. So y can't be 0. So let me go back and amend this original definition. You ask, can it go as far left as it wants? Yes. As far right as it wants? Yes. Are there any gaps in the middle? Y's, can it go as high as it wants? Yes. As low as it wants? Yes. Are there any gaps as you move up to down? Okay. We'll talk through these as we go. Okay? When you type this one in your calculator, make sure you put a parenthesis around the bottom to keep the whole bottom together. Can this go as far left as it wants, as far down? Yep. There are arrows on the ends of all these. Okay? But there are still these asymptotes. There's a horizontal one here, and now this vertical one is here. Okay? Domain, left, yes, right, yes, but there's a gap vertically as you move left to right at -4. 1, 2, 3, 4. So x cannot be -4. Range, can it go as high as it wants? Yes. As low as it wants? Yes. But as you move up to down, there's this gap, this asymptote at 0. So y cannot be 0. Okay? I'll type this one in to show you, to make sure you're seeing how to type it in. So y equals clear. If you use this alpha y equals, enter, a 1, come to the bottom, x, now I need to get out of that fraction and do subtract 5, so you arrow to the right, -5. Okay? Graph. There it is. It can go as high, left, down, right as it wants. But there are these horizontal asymptotes here. There's a horizontal asymptote here and a vertical asymptote there. So it can go as far left, domain, as far right, but there's a gap at 0. X cannot be 0. Range, high as it wants, low as it wants. But as you go up to down, there's a gap, and the gap is occurring at -5. So y cannot be -5. Okay, all this together, parentheses, type it in. Here you go. These continue on forever left to right and up and down. But there's an asymptote running here and an asymptote running there. Okay? So left to right, it goes as far left and as far right as you want. But there's a gap, and that gap is at 1, 2, 3, 4. So x cannot be -4. It can go as high as it wants. It can go as low as it wants. But up to down, there's a gap, and that gap is occurring at -5. Y cannot be -5. Okay? You would type this in like the others. Up to down, left to right, it's all good. But there are these asymptotes that are running here and here. Okay? Left to right, it's occurring, and I'm a little off, at -4. X cannot be -4, left to right. Up to down, there's a gap at -5. Y cannot be -5. Okay, we're getting there. I know it's long. I'm so sorry. I'm so sorry. 1 over x squared creates this graph. This doesn't join. These continue to go up, and they never touch. These continue to go up, and they never touch, left and right. So domain, can you go as far left as you want? Yes. As far right as you want? Yes. But there's this gap in between. X cannot be 0. There's a vertical asymptote there. There's a horizontal asymptote here. If it's a horizontal asymptote, it goes as high as it wants, but it doesn't go as low as it wants. It will never touch that asymptote. So y is strictly greater than 0, because it's just from 0 up, but it doesn't include the 0 because of the asymptote. These go up, but they never join, left and right. Okay? Domain, you can go as far left as you want, as far right as you want, but you got this gap, and the gap, because of that vertical asymptote right here, is 1, 2, 3, 4. So x cannot be 4. Range, you can go as high as you want, but you can't go as low as you want because of the horizontal asymptote. The horizontal asymptote is at 0, so it's just like this one. Y is greater than 0. It does not include it because it's of that asymptote. Okay? These continue up. There's arrows there, but they never join. They never touch because of the vertical asymptote running here. And there's a horizontal asymptote that's running there. Range. Sorry, domain. Left to right. There's a gap at 0. So x cannot be 0. Up to down, it can go as high as it wants, but it can't go as low as it wants. And if I didn't draw all that there, you would see that it's 5. So y is greater than 5. Okay? Now this one opens down. These never touch. They go left to right. There's a vertical asymptote here, a horizontal asymptote there. Left to right is all good except in the middle where there's a gap. So x cannot be 0. Up to down, y's can be from there down, but because of that horizontal asymptote, it doesn't include it. So y is strictly less than -4. Oh, sorry, positive 5. Positive 5. What am I saying? Okay. All right, some trig functions. I guarantee this is the last screen, you guys. I'm so sorry. Okay, deep breath. Here we go. To graph them on your calculator, y equals, clear, sine is right there, sine x. Graph it. Now, if your graph, and I'm sorry I got to go here, you hit mode. If you don't, what you need to do is have it set not in degrees, but radians. And all you're going to do is just like changing a setting on a cell phone. If it's in degrees, you need to have it in radians. You just hover over it and hit enter. On this, so let me get rid of that. If it was sine parenthesis x, parenthesis x, if I graph it as is, you guys won't see much. It's just this in the middle. That's because it needs to be in radians. You need to change it. That's where you change the setting in radians. Plot. Once you set it in radians, you don't need to set it again. There it is there. Okay? Once it's set it in radians, you don't need to change it back. Okay? Domain. Can the graph go as far left as it wants? Yeah, it keeps doing this wiggling forever and ever and ever. It keeps wiggling as far as it wants. Yeah, left and right, it goes as far as it wants. So it's all real numbers. Now the range, it's trapped. It only goes as high as 1, only goes as low as -1. Only goes as high as 1 and as low as -1. Smaller number on the left, bigger number on the right. When you have a negative sin x, now make sure you use negative, not subtraction. It looks similar. All reals, and it's still trapped, so it's a horrible all reals. It's still trapped between -1 and 1. Okay? Now this one's been lifted, but 4 units up. So if it was lifted 4 units up, it's going to be trapped between 5 and 3. Now I know that's small, I'm sorry. You can also see it if I added 4 to both of these. It's trapped between, because that's what it did, it lifted it 4 units. Add 4, you get 3. Add 4, you get 5. That's how I got those numbers. Okay? Looks very similar. It goes on forever left to right, and it's trapped between -1 and 1. Negative cosine, same dealio. The y's are trapped between -1 and 1. This has been moved down 3 units, so that doesn't affect your left to right. Now subtract 3 from both of those, because they've been dropped 3 units. So that's -4 and -2. That's where it is. It's trapped. As high as it goes is -2, and as low as it goes is -4. Okay? So sorry for the length of this. Oh, yep, can't say it enough. Thank you, bye.